Okay, good evening, everyone, and welcome back to the cloud computing class. So in the last class, we had basically started our discussion about automatic scaling groups in Amazon EC2 platform. Essentially, what it helps us to achieve is to basically express the factors of elasticity when it comes to kind of launching multiple EC2 instances within our VPC, okay, which can be kind of distributed across different subnets within a particular availability region, right? So the two main things that we talked about was the fact that when you go into automatic scaling groups and when you are creating an auto scaling group, basically the main thing that you need, first of all, is what we call as a launch template, right? And in the launch template, you can essentially create what is known as the different specifications that the auto scaling group will follow in order to launch these different EC2 instances that you plan to kind of execute across your VPC itself. So the main thing that we have to keep in mind is when we are kind of moving into launch templates, the factors that you have to take into account is the fact that your Amazon machine image, that's the guest operating system that you're going to be using, is going to be the same. You will have a similar set of instance types, and then you have to specify your key pair for your authentication if you're going to be SSHing into any of the particular EC2 instances that you launch through the ASG. And then security groups by default will also be associated. And in short, what we're trying to kind of get at is basically you will be launching a set of K number of homogeneous EC2 instances. What you do thereafter is once you create the launch template, you kind of associate that to your auto scaling group, which is basically the platform or the portal that will take these configuration specifications, and then it will launch K number of EC2 instances as specified in the auto scaling group. And within the auto scaling group, you have the ability to specify what will be the minimum number of instances that the ASG needs to launch, what is your desired number of instances, and what is the maximum number of instances that you can kind of, or that you would like to have this auto scaling group launch for you or maintain for you when you are scaling up. So in addition to that, we also talked about target tracking or dynamic target tracking when you're working with auto scaling groups. So essentially what you can achieve there is that if you go to the automatic scaling of your ASG option, there you can specify not just the number of instances, the minimum, maximum, and the desired number of instances that you need to kind of maintain, but you are also capable of specifying any particular performance matrix that would be associated to your EC2 instances. For example, the one that we talked about was basically CPU load, right? So to continue down that line and continue our discussion, what we are going to be talking about, the last aspect that is there in the EC2 service provisioning is basically the idea of load balances, right? So I will introduce you to how you create target groups and then how you declare your load balances, and then leave it up to you as a self-exercise to kind of integrate the load balances within your auto scaling group. Because essentially, if you recall from the last exercise again, when it comes to the declaration of auto scaling groups, you do have the ability to kind of specify whether or not you want to use what we call as the elastic load balancer, right? So previously in the last exercise, since we had not talked about load balancing yet, we had opted for the fact that no load balancer is present when we were declaring our auto scaling groups, right? But now, since we can kind of work with our load balancers and we can declare our target groups, then essentially that single step where you have the ability when you are declaring an auto scaling group to select an ELB kind of is available to us at that point of time. So the only difference when it comes to working with elastic load balancers and then integrating that to auto scaling groups is the fact that if you remember when we were talking about ASG itself, this was the architectural diagram that we were kind of working with, the conceptual idea behind this, right? So whereas that if you create a cluster of EC2 instances that is being provided or that is being monitored or maintained by auto scaling group process, right? In supplement To that, we also had Amazon CloudWatch that was providing us with the monitoring services, because CloudWatch essentially was the main service that was keeping a track of how or what is the health of the different EC2 instances that you launch within that particular cluster or that you have declared within that particular configuration. And then CloudWatch kind of reports back to the ASG process, which is responsible for taking decisions based on whether it should create a new instance, whether it should destroy an old instance and stuff like that, right? And in this process, if you want to track not just the health of EC2 instances, and by that, what we are trying to say is that whether the instance is alive or is it dead, it has crashed and stuff like that. But if you also want to kind of keep a track of dynamic target tracking policies, such as CPU load and stuff like that, then that is also a responsibility which is kind of dispensed by CloudWatch itself, that CloudWatch is directly communicating with these individual instances with respect to how it is doing, right? But in terms of an actual application that you're going to be deploying on these EC2 instances, for example, let's say if your cluster of your ASG, where all your EC2 instances are, they are a part of a web service, a front-facing application, which will be pinged by clients from outside this trusted boundary, right? And then during that situation, or for that kind of architectural situation, what you want to ensure is that whenever a client request comes, it does not flood any particular EC2 instances, which is acting as a server in that particular case, within your deployment, right? Within your deployment architecture. So with that in mind, what happens is that the ASG architecture is kind of supplemented by another process, right? Which is what we call as the Amazon Web Services Elastic Load Balancers, okay? Which is, the acronym is basically ELB. And the whole point of ELB is that ELB kind of takes over the governance aspect or the maintenance aspect from the ASG process itself. So ASG is not completely responsible at that point of time when you put an ELB for the maintenance and the checkup of the life or the health of the EC2 instances. So there are two things that is happening here that the ELB is taking care. The main thing that the ELB is taking care of is basically an optimized distribution of the routing requests that will come from either users or that will be generated from within itself, right? So even if the different EC2 instances are kind of performing some kind of process and it is responsible for, let's say, rerouting traffic to other EC2 instances based on whatever processing is happening on a particular EC2 instances, then that will not be an example of a front-facing load balancers, but it will be something along the lines of a network load balancer, because it's just responsible for rerouting the traffic within the internal EC2 architecture, right? Or within the internal ASG cluster that you have created, essentially. There are also gateway. Previously, there was a classic load balancers for other purposes, but now it has been phased out from the AWS platform. Instead of a classic load balancer, what we now have is they call it as a gateway load balancer. So essentially, a gateway node is replaced by an ELB, or you have an ELB there in order to reroute the traffics in an optimized fashion, right? So again, just to kind of boil it down, the main purpose of the ELB is to route any kind of network traffic. That traffic could be front-facing, that could be coming from the users itself, depending on the type of applications that you're hosting behind the ELB, or it could be simple internal network traffic between the different EC2 instances, and you just want to kind of balance it out, right? So in that situation, you will have a back-end ELB and not a front-facing ELB, right? So when a ELB is trying to route the traffic as well, it also has to know whether whatever the EC2 instances, which is kind of lying behind that ELB, is available or not. So in the off chance that the ELB does not find the EC2 instance that it is trying to route the traffic to is not responding. So that is something that it will inform to the auto-scaling group. And then the auto-scaling group will make the decision that, hey, is everything all right or not? It will talk to CloudWatch, and if CloudWatch tells it that, hey, it's not working, yes, there was supposed to be, let's say, 6 instances, but right now there is 5, then ASG will make that decision that, hey, it needs to start a new EC2 instances in order to meet the desired criteria of elasticity at that point of time. And the same goes for the fact that if you have a dynamic target tracking policy and not just the fact that whether or not the EC2 instance is alive or not, then in case, let's say, for example, in our last exercise, what we did in the dynamic target tracking policies, if the CPU usage goes above, let's say 50% or something like that, then also the auto scaling group will take an action and it will kind of introduce another EC2 instances in order to balance out the load. So there are two things that will happen when you kind of integrate an ELB to your ASG architecture. The first one is the ASG elasticity factor. It's still there, right? So ASG is taking care of that. But when you put an ELB, that basically is responsible now for optimally rerouting the traffic and distributing the traffic across all the available instances that are there, right? So essentially, in addition to elasticity, right, what you get by introducing the ELB in this type of architecture is that you also increase the availability of your architecture, and it also increases the fault tolerance aspects of your architecture as well, right? So the health check, instead of being completely done by CloudWatch at that point of time when you have an ELB present, is basically rendered or dispensed by the load balancer, right? Instead of completely depending on CloudWatch, the ELB takes over that role of monitoring as to what is going on with the different EC2 instances and then notifying the auto scaling group, right? So CloudWatch is not solely responsible for taking care of that particular aspect when it comes to putting a elastic load balances either in the front or in the back end side of your architecture that you are developing, right? So in order to set up an ELB, of course, if you want to put it in this architecture, you have to take it through the declaration of auto scaling group, because remember, auto scaling group, if you think about it in a way, you should remember that it is a way of deploying multiple EC2 instances with the elasticity factor tuned into that particular architecture instead of declaring instances one by one, right? So that is the main thing that you have to remember with respect to ASGs, right? But when you first want to work with ELBs, it's a two-step process. The first process, what we call as, is we have to declare what is known as the target groups, right? So again, what are you trying to monitor here? What is it that is going to be monitored when the load balances is going to be set up? And this target group is basically an input field with your load balancer itself. So that means when you're setting up the ELB itself, you need to specify what is the target group and what protocol is that load balancers responsible for. Because remember, we just said the fact that the ELB's main job is to optimally distribute the traffic. So that means the ELB needs to know what kind of traffic is it actually responsible for routing, right? So for example, if the protocol is HTTP, then the ELB will be receiving HTTP protocol requests from the user, and that is the traffic that it will be rerouting across all the EC2 instances that will be under its command, right? Or under its maintenance or monitoring, right? So let us go ahead, and what I will help you understand is how to set up the target group and how to create the ELB. And then what I will leave up to you is basically follow the steps that are given in the next two slides, which is the same as the one that we did, which is essentially to transform EC2 instance into a web server. We had done this exercise probably a class or two ago, right? But in addition to that, we have some flavor that I have introduced into it. And this two files that you will need is essentially present in Moodle itself. And the whole point of having these two files and not having the process or the software that we had installed previously, and we're taking it a little bit further, is it will actually give you a demo of the ELB in action. So what this does is this file that you see here, names, this just has random names. And then every time you run this particular command, right, you are essentially going to, in your index.txt, which will become your HTML file for each EC2 instance, it will apply that unique name to each EC2 instance. So that means when you will be pinging your load balancer, and the load balancers, the goal is to reroute the traffic. So every time a different EC2 instance technically should be responding to your request if you continue to ping your load balancers. So that means if I ping this load balancer's public DNS URL for the first time, maybe it gives me a response or it routes the traffic to, let's say, EC2 instance 1. And EC2 instance 1, let's say, has a name ABC. So you will see basically a hello message in the form of an HTML file with that name there, that, hey, hello from ABC instance. And then you refresh it and ping it again, it might send you to the second instance and the third instance and so on. And then it will cycle back again, depending on the number of instances, right? If you do not give this separate naming when you're trying to demo this, right, then you wouldn't, like, it will be behaving underneath that it will be doing its job, but you will not be able to validate that, right? So that is the reason why we have this extra step here, where we are trying to give additional names to it. If you don't want to go through this process, which is kind of like an automated script, then all you have to do is SSH into your individual EC2 instances that will be launched by the ASG. And then you just have to put a HTML page in this particular directory, and you just have to give it a different name, right? So whatever it is that you wish to do, as long as you can understand that your load balancer is actually working. Okay, so coming back to setting up an ELB, the first thing that we would want to do, and this slide is again available on Moodle, so if anybody wants to follow that. But the first thing that we need to do is, of course, log into our IAM user account, make sure that we are in the correct region. And this is basically the EC2 service, the EC2 dashboard that we're looking at. All of you should be familiar with it at this point of time. The first thing that we do is we move on to, from the left vertical menu inside our load balancing stuff, we just go to the target group. Okay, so in target group, this is the fresh page. If you have not declared any target group, this is what you will be seeing. So if you do not see this option here, for those who have worked before or tested it out, maybe you can always click this and it takes you to the same process. So you hit create target group and it will ask you that what is it that you are trying to monitor, right? What are the different categorical services that you are essentially trying to monitor? So you can see here, we have 4 different target types when it comes to working with target groups, right? So this is what the ELB will essentially monitor. Remember, that is what a target group is. That is, what are you trying to monitor? Are you trying to monitor different IP addresses, right? So that means, let's say if you have 4 or 5, just making up a number, let's say elastic IP addresses, which is the static public IP addresses that you can have Amazon basically assign you when you're working with your configurations. And you can use that as a front-end IP addresses in order to kind of specify your different web server addresses, right? So if that is the situation, if you want to route between multiple IP addresses and you want to make sure that no particular IP addresses gets flooded with all the network traffic, then you would probably be monitoring different IP addresses. Similarly, if you have the execution of Lambda functions, as we discussed, this is what enables serverless architecture, then you can use the Lambda function. Similarly, you have the option for application load balancers, which is basically kind of facilitating the routing between the different TCP requests that happens within a particular VPC, right? So what we are going to do is basically, for this particular exercise that we will be executing, we basically have EC2 instances, right? So if you look at the architecture that we were discussing about, we essentially have EC2 instances that is sitting behind the load balancer, right? So the target group will be all of these different EC2 instances that will be launched within the ASG. So when we declare our Elastic Load Balancer itself, we will assign this target group that we are creating right now to the Elastic Load Balancer, and then put that Elastic Load Balancers within the declaration of our auto scaling group itself, right? So that is the path that we are going to be taking. So we will keep the selection here to instances. We need to give this a name. So I will just give something like demo-target group. You can give any other name that you want. Okay, you have to specify the protocol that is going to be monitored essentially. So you can see here, the basic web service protocol is already selected. So it has the monitoring of HTTP on port 80. If you want to change that to HTTPS, you can change that. The port will essentially change based on that. right? But if you want to move on to any kind of TCP network traffic, UDP network traffic, TLS network traffic, so you can all select that, right? And I don't know very well about this Genève network traffic, but you can look that up if there is ever a situation where that is kind of relatable to you, right? So you can keep this at default. If you want to select HTTPS, you can select HTTPS, because the exercise, essentially what we are doing is setting up a HTTP server here, right? Remember, if you have an HTTP port here, when you ping the public DNS, make sure you change the HTTPS, which is the default protocol right now on our browsers for security purposes, to HTTP. Okay, this is important. That is, when you take a URL service and when you kind of paste it, you can see here there's an HTTPS by default that is added. So when you will be pasting the public DNS of your Elastic Load Balancer, you might not see anything at first. And the reason why is because if the default value that you have selected here is basically HTTP and port 80, you need to ensure that you are typing HTTP here as well, and not HTTPS. If you don't want to go through that process, please make sure that you pick up and select HTTPS, whatever you do. The second thing that you have to keep in mind is, because this is a network traffic that will be coming into your ASG, or basically into your EC2 instances, then the security group that you associate with your ASG autoscaling group must allow for the incoming traffic of HTTP 80 or HTTPS 443. If that is not there, then that could be another second reason why your demo might not work, right? So those are the two things that you have to keep in mind. You always have to select a VPC to which this is associated with, right? So here we only have the default VPC that we are working with in Ohio. Each VPC can have its own target tracking groups. The protocol versions, you can select which protocol version you're using. The health check will be based on the HTTP routing protocol that will be kind of facilitated by the load balancers. You can give it some tags if you want to. There are some advanced health check options, which we are going to leave as default right now. But essentially what this allows you is to specify how frequently you are going to check the health of different EC2 instances that will be monitored by the ELB itself. Okay, so next, and then port selected, we want to just monitor port 80. We don't have any kind of targets that are associated right now because we have not created any kind of EC2 instances. So you don't see any particular instances that belongs to this target group. So what we are essentially doing right now is just creating the target group template, right? But once we create the target group template, we essentially have to register the targets within that target group. Please remember this, right? Because right now we are just setting up what will be monitored. So we are saying that instances will be monitored. It will be monitoring the HTTP port 80 network traffic. And then there are many other factors with respect to how frequently should the ELB keep on checking the health of these instances. But the second step of target groups is to basically actually register the target itself, right? So here the steps should be that if you have EC2 instances that are already running, then you would have the option here to kind of add those different available instances. So here you can see that there is no available instances to this particular target group when you're creating it, right? So it's about like, which step do you do first? Do you create the instances first and then add them to the target group and then the load balancers? Or do you create all the categorization values and then once you launch the instances, you just add them, right? So this policy that we are following is kind of similar, if you think about it, to how we work with IAM. So it's like asking, should you create user accounts first and then assign them to the user groups? Or should you create user groups first, and then once user accounts are created, you just assign them to the group that they belong to? So we are taking the step that we followed, or the policy that we followed when working with IAM, is that we are first creating the group, right? So this is the target group that we are working with. And then later on, when the instances are created, we just assign those instances to this group without having to take or worry about individual instances. So right now, this is going to be empty and we're just going to leave it empty, right? So we don't have to worry about it. So we just click target, create target group, and then the target group is generated. And the very next step right now with the target group is to associate it to a load balancer, because all the target group is the configuration specifications of the target group, all it says, monitor EC2 instances, monitor for HTTP traffic at port 80, and then it has some health checking values, right? What is the frequency values of different health check, right? So now we have to kind of plug this in to a load balancers, which will be able to take all this specification information and then execute it, right? Essentially whenever it needs to. So the next step that we need to do is, this is done, we need to go to load balancers again from the left vertical menu. And then we need to hit on create load balancers. So you can either create load balancers here from top right, or you can create load balancer here if you were looking at this for the first time. Okay, so you hit create load balancers and it will show you the 3 different types of load balancers that is supported by the AWS platform, right? So we have the application load balancers, we have the internal one, which is the network load balancers, and then we have the different gateway load balancers, which is kind of a bridge between different types of networks itself. Previously, we didn't have gateway load balancers going as recently as back as about like 8 months or so. It got phased out around summer last year, more or less. Okay, so essentially, before this, we just had the classic load balancer, right? So load balancer for any purpose that was there. So that was essentially phased out, right? So it's still here, right? So they're still showing it here, but we don't use this anymore, right? So it doesn't matter here what traffic you're using. You can basically distribute any different type of traffics here, right? But here there is some specificities with respect to the categorizations of what type of traffic that you're trying to monitor. So for us, the one that we are trying to do is basically this one, right? Because in the target group, we specified HTTP and HTTPS. So in application load balancers, we are essentially going to click on create, okay? So it asks for a name. So let us just say demo dash load balancer test. Okay, so give it a name. It's going to be an internet facing load balancers because it will be fending request from the public domain, right? That will be coming into your load balancers. If it is something that will be happening within your VPC itself, which uses private IP addresses, remember when we see private IP addresses, basically what we are looking into is a network traffic that takes place between EC2 instances within the subnets, right? Inter-subnets, not necessarily it has to be intra-subnet, but it could be inter-subnet as well, because the communication between EC2 instances that belong to the same VPC, okay, takes place by using the private IP and the VPC router itself. All right, so that will basically be internal. Okay, the other option that you have here is what type of IP address that you're using. We know that we are using IPv4 addresses. We know that for a fact because our VPC has been assigned the IPv4 scheme. The CIDR blocks that we use for our VPC essentially uses IPv6, right? We don't have a hybrid combination. In any situation, if you have a hybrid combination, then you can essentially click on this third option, or sorry, this other option, alternative option, which is the dual stack, where you have a combination of both IPv4 and IPv6 addresses. So that depends essentially on your architecture, like what you have and what you're working with, okay? Network mapping is required. That is where this elastic load balancers will be sitting. So you need to select on the VPC and you need to select on the different subnets, which will be a part of your deployment architecture. So what I mean by this is that if you, let's say, if you remember in the ASG, we had to, at the very end, we had to specify which subnets will be a part of the deployment architecture of the ASG, right? So that means that when you are kind of declaring this cluster here, right, will these EC2 instances be deployed to a single subnet? Will it be deployed to all of the subnets and distributed equally? What should be the deployment architecture? So knowing your deployment architecture is important when you're working with this kind of like situation. So here we are going to say use all of the different subnets that are available within our VPC, right? So we just select on the 3 different public subnets that are by default available to us. And then we basically move on to security group. Now this, again, we keep on reiterating this factor. Security groups are very important. If something doesn't run in your demo, in your architecture, this is one of the first few things that you should check whether or not you are actually allowing for that traffic to come in, right? Because there are 2 layers of firewalls that are associated in your VPC architecture. The first layer is at the subnet level. Remember that you have a network access control list, or better known as NACL. And then on the EC2 instance level, there is another firewall, which we call as security group. So always make sure that in case you get into any kind of trouble, the first few things that you should check is that whether or not your firewall policy is appropriately configured to handle the type of traffic that you're dealing with, right? So that is what you're going to work with. So you can specify any number of different security groups, and it will check it individually, like one after the other. It will check if any of the network traffic is there. So we already have this created for us, the demo SG Ohio. What we need to ensure here is that this allows for the HTTP traffic, the protocol traffic that we have specified here in terms of the listeners and routing that will happen. And also, this is kind of connected to our target group. So when you see this, it will ask for the target group as well. So now we have the target group that we have created, which kind of specifies monitors instances for IPv4 traffic for HTTP port 80. This and this same, right? Otherwise, there will be a problem if there is a mismatch based on what you are telling the ELB to manage and what the target groups are actually managing, right? So this too kind of needs to be in the similar path. And what you have to ensure is that this security group that you have added, or this default security group that you want to incorporate, must allow for this network traffic, because otherwise it will be dropped, right? When it comes through the ELB and tries to go to the EC2 instance, it will be dropped by the security group that is protecting the instance itself, right? So we don't need this default group, because I think we already have all our traffics that we are working with in this particular security group. Just to double check it, let us just go there quickly to our security group, which is also in the EC2 dashboard. So security group, where is it? Security group. Okay, so here we have created this one, demo SG. So go here, check all our network traffics for our inbound. Since it allows inbound, it will also allow the outbound. So we don't have to worry about outbound separately. We have to do that in network ACL. We have the remote desktop protocol, HTTPS, HTTP, SSH, right? So we already have this. This is what we are looking for. If you guys are doing with HTTPS on 443, just make sure that this is there. You can change where the addresses or where the traffic is originating from. Right now, I have for myself set it up to accept it from anywhere that is public, right? Outside the Amazon platform. So anyways, so if you want to add on any kind of services with respect to like accelerators of your routing traffic, you can add this. If you add this, that will cost you some money. Right now, since we're in the free tier, we are not going to check that box. For every declaration, we get tags here, so I'm not going to continue talking about this. Make sure when you're in the production environment, when you're working it for a practical scenario, you do add tags, right? For demo, you can skip it, but for actual situation, this is just like writing your comments in your programming code, right? If you're just testing yourself, it's okay, you can ignore some of this, but if you're working in a proper environment, then please make sure that you comment your codes, right? So similarly, please make sure that if you're working in a proper cloud environment, put tags, it is necessary, okay? So then once everything is done, just hit create load balances, and then the load balances is basically you have created it. And now all you have to do is integrate this load balancer to your ASG configuration when you're working with it, right? So right now you have to give it some time here because essentially it will take to kind of provision that load balancers. It's essentially launching a front-facing process. All you need to do is that stick this process into your architecture now. That is the last step that you have to take into account. So when you get into this load balancer, essentially, again, keep a note of all of these different tags that are available on top or wherever you want to call it. Essentially, you have some sub options here. So if you want to monitor what is happening with the resources, that is for this load balancer. Right now, it is not associated to any kind of EC2 instances. So it will not show you anything happening there. If you want to look into the security, it will show you the security group here itself that is associated with the load balancers. Network mapping is also something that it will give you, where it is kind of deployed, what are the different subnets are under its command, how much IP addresses are available, and those kind of things, right? So the next step, and I will kind of walk you through the process of what the next step is to kind of go through slides 19 to just 22, right? 4 slides or so, in which half of the steps are basically to do that automated optional step where you don't manually go and SSH into each and every EC2 instances that will be launched within an ASG and create your own personal HTML file that can uniquely identify that particular instance, but you can automate that process. So from kind of like slides 19 and then 21, that is optional if you don't want to follow. 2022 is where you have to basically follow that, right? In order to set this up. So all you have to do is you have to take this and you have to put this inside your auto scaling group. So what you do there is you go to your auto scaling group, you create an auto scaling group, and you kind of give it a name. So you can say test ASG with ELB. So you can give it something like this, okay? If you already have a launch template, so this is something from our previous class. If you want to do that, then you can just select that particular launch template. Or if you want to create your own launch template, then again, click on this. It will take you to the new launch template. And here you can give it LT for ELB ASG. So essentially launch template for elastic load balancers and ASG. Here you can give it test for elastic load balancer. So you can provide that. You have to select a machine image. So let's just go here, click on our AWS machine image, AMI, right? For Linux. The instance type, we need to have an instance type. So we will select the T2 micro, always free tier. That's what we want to select. We need a key pair. I will select my own key pair. Network settings, we will just select an existing security group. So existing security group selected, done. Volume, we will keep the default volume here, 8 gigs SSD, okay? And then in the additional details, if you go down, this is where you will have the user data, right? So the user data that you see in the slides and in slide 21, that is what you will be typing out here. Again, please do not copy paste from the PowerPoint because there will be some encoding problem that you might have if you're directly copying it from PowerPoint. So just type it out if you want. If you do not want to do it, that's fine. Then the only other option, in order to actually validate the working of the ELB, you will have to SSH into the individual terminals or individual EC2 instances. And then you will essentially have to run all those individual commands, which could have been automated. So you decide what is it that you want to do, right? So once you set this up, you get to create the launch template itself. And then once the launch template is ready, you come here, you select the launch template, and then you essentially go to next, okay? And there you will select all of the different availability zones because that's where our ELB is also kind of monitoring. So we want the auto scaling group to also use all of the different subnets that are essentially there. Keep going next. Okay, so here, this is the step where you will basically drop the load balancer. So in the first exercise, when we were just learning about elasticity and auto scaling groups, we selected no load balancers, right? But we have a load balancers right now. So we will just attach an existing load balancer. And if you follow the steps of attaching a new load balancer, then you have to just redo the target group thing and the elastic load balancer steps that we did separately, right? So that will be essentially a singular process that will be initiated from the declaration of ASGs itself, right? So we already have something set up for ourselves. So our target group is ready. So we are just going to select the target group, and our ELB is also monitoring this target group. So that is where the integration or the synchronization takes place. You can either change this if you want to modify this, or you can leave this as is, right? And you go next. Here, it will ask you again the same question. What is your desired capacity, minimum capacity? So I will just say 2 on your desired, 2 on your minimum, and then let's say 6 on your maximum. And then you can do target tracking scaling policies. That is, now you can put your CPU utilization rate on top of it. So essentially what we are seeing right now is basically an integration of all the individual steps that we kind of saw in the previous few exercises. And we are bringing that together into a single architectural deployment, right? So you can change the values and whatever that is you want it to do. And then if you want to provide notification, we talked about this already. You can add it to SNS, add options if you want to, review all the information, and then create auto-scaling group. So the moment I hit create auto-scaling group here, it will create all the EC2 instances, but note that I kind of skipped the part where I transform all these EC2 instances into a web server. So please make sure that you do that part there and follow all the rest of the steps of dropping the ELB. And then when you are going to launch or test your load balancer in action, essentially, right? So essentially what you need to do there is you need to ping this address. This is the DNS that you need to ping. Okay, so you don't want to ping. Remember in the previous web server exercise that we did when we were working with a singular EC2 instance, we pinged the public IP or the public DNS of the individual instances. When we put our load balancers, we don't provide the individual addresses of the EC2 instances. Otherwise, the whole purpose of rerouting the traffic is defeated. So the only thing that we will provide to clients is basically a mapping to the DNS of the load balancer itself. So when you ping the load balancer through the target group synchronization will reroute the traffic to the EC2 instances that is managed by the ASG. Okay, so keep that in mind when you are working with ASG itself. So anytime you purchase a particular domain, that domain will be mapped onto the DNS of the load balancer. And then the load balancer will take care of what is happening underneath it and to distribute everything around it, right? So that is basically the gist of how you work with the load balancer itself. So any questions? Any particular questions?
Yeah, I have a question.
Yeah.
So if we didn't add the script when we launched the templates, does that mean we're going to need to go to each instance?
Yes.
Okay.
So you need to kind of terminal into each of those instances and then just run those commands individually. But you can skip the S3 bucket process then. You don't need that.
Okay. Is there no way to like run commands like on all the instances at once?
Once it is launched, no.
Okay.
No, the fastest way, the amount of time it will take for you to destroy those instances, wait for it, and then start a new one, that is probably the closest that comes to saving some time. So what you can do is you can kill that ASG that you launched, and while it is being terminated, you can start your another ASG, because the only thing that you have to essentially change is the launch template itself. Everything else will remain the same. So you can kill the existing ASG, it will terminate all of the instances, and then you can go for another ASG deployment with a new launch template.
Okay, sounds good.
Yeah. Okay. Any other questions? All right. So again, remember, once you are done, please delete this just as a good practice of not keeping anything running, because we're just demoing everything. So select your load balancer, go to action, okay, and then go to delete load balancer, and it will ask you to confirm for some reason, and then we will just copy paste it instead of typing it out, and then we will just delete the load balancers. Target group in itself, they are not monitoring anything. They're just like a template of what needs to be monitored. So it's not going to cost you any money as such, but as a good practice, again, we just want to make sure that we don't have any resources created or running or taking any kind of space there that we forget later on and causes us to kind of pay anything, right? So these are the different things that you have to make sure that you perform and you delete, right? Again, as a best habit, just make sure that you delete everything. Just keep on deleting everything. Keep a note of what you're creating and then delete it once it is done. That is a good practice, okay? And anytime that if you forget what is happening, you can simply just go back to your EC2 dashboard, and it will kind of show you what is happening. If you want to get a much bigger picture of what is happening, you can go to the EC2 global view that kind of spans across all the regions that you're working in, and it will show you what is running in each of those regions. If you want to take it a step further, then you can go to the VPC dashboard, because that will capture more than just the EC2 applications. And that will also give you an understanding of what is going on with your resources. Okay, in case you forget if you have anything running or not. Okay, so that's the option. All right, so this is mostly about the instances. So now we can kind of move into the next part, which is storage, and then kind of make our way towards databases on EC2 instances. So when it comes to storage, there are essentially three main services that helps us around within the AWS platform, right? So this is essentially in our next slide, which is AWS storage services. Okay, so I'm not sure if I have uploaded that to Moodle, so let me go ahead and check that real quick. Okay, so when it comes to storage services, as we discussed, there are three different storage services that is available for our utilization. Okay, so two of them are basically within the AZs that we are working on, right? So these deployments, the first one that is known as Elastic Block Storage, and the second one that is known as Elastic File Storage, these are basically deployed within the AZs or the availability zones that we are working with, right? S3, or the simple storage service, okay, is deployed across the entire availability region. Okay, so you can ping S3 across wherever your deployment is with respect to if, let's say, an EC2 service that is trying to communicate with S3 or something along those lines, as we saw in the exercise of IAM roles, right? So the way we are going to do this is, first of all, conceptually understand what these services are, where it is deployed, what is the distinguishing features of these three different services, and then specifically talk about how we can set this up from EC2. As you can see here, the Elastic Block Store is a service that is associated with EC2 itself. However, the other two services, which is basically the Elastic File Storage, is a separate service. It's not a part of EC2 itself. So we have to go separately and then connect it to our EC2 instance. The only notable thing that you have to keep in mind is EFS is mainly meant for Linux distribution. You don't get to work with EFS when it comes to Windows distribution, because it is not a network drive. It is basically a file system. So you essentially need to mount it, right? So when you want to do that, you're essentially working with Linux distributions, specifically speaking. And then finally, we have the S3, which is also a separate service. So we have to kind of go to that service outside of the EC2 service itself. However, the EBS service is something that we have within EC2 itself, that we can kind of find it there itself. Okay. Other than that, if you search for EBS separately for a service, that will take you to what is called as Elastic Beanstalk, which is another better way to kind of work with web application, and it supports much more technology than to set up a standalone Apache web server and then running a code or hosting a code through that. Instead of doing that, you can use all the available technology. We'll talk about Elastic Beanstalks. That will be different. So don't get confused between these two. Sometimes people just say, oh, use the EBS with EC2, then they're referring to the storage, but then there is an EBS, which is for web application development, which is a little bit different, right? So anyways, coming to Elastic Block Store, the main thing that we have to kind of not learn, but just look at is the idea of snapshots, which is essentially, that is the feature that enables us to take backups of our existing data that will be stored through or generated through our EC2 instances. And these snapshot is also another way of where we can create our own machine image from scratch. Okay. So we can do that through snapshot, and we can take that and we can put it in the Amazon marketplace, or essentially what they call as the AMI catalog here. So we're going to work through that. Then we're going to do the EFS. And then finally, we're going to revisit S3 again. Remember, we saw S3 a little bit on a very high level overview when we were working on the previous exercises, right? So, but here for S3, what we will specifically talk about is how to do version controlling. and how to kind of set up different permission policies other than setting everything as public and leaving it kind of vulnerable to public access, right? So we're going to see through those two main features and when we talk about S3 itself, okay? So when we look into elastic block storage, you kind of get four options with respect to what type of storage volume do you want to associate with your EC2 instances that you're going to be launching within a particular public subnet inside of your VPC architecture, right? So the default one that you get is the general purpose that is kind of referred to as using the GP3. Essentially, that is an SSD or an SDD, sorry, not SSD. And then you have the ones which are kind of tailor-made for input-output operations per second, or the IOPS operation. So those volumes will be kind of categorized using IO2, okay? And then you have the hard disk drive based, where you have the throughput optimized, and then you have the cold storage. So the cold storage, essentially what happens is that if you have a storage or if you have a set of data which you're not referring to very often, you know, once in a day or once in multiple days, you need to refer to that data. That is when you kind of put your information into the cold storage, or you store it in the cold storage. Throughput optimized is when you kind of need a large amount of data back and forth, but you don't do it very frequently. Then you kind of use this throughput optimized. If you're going to be performing input-output operations on your data, that you're reading the data and writing the data very frequently, unlike in bulk compared to your throughput optimized, then you would need provisioned IOPS. And for everything else, you have the general purpose, right? So that is basically the block storage categorization that is available on AWS. And what you do is you take this block store and you attach that to your EC2 instances, and that's it. You work with it as a local computer, right? File storage in comparison to block storage is a little bit different. So what we're doing is that this is not a disk drive. So this is not a volume, okay? So this will not be created as a disk drive within your EC2 instances. You cannot partition it. So in elastic block storage, you can partition it, just like you can partition any of your disk drives, let's say on your Windows machine and stuff like that. You cannot partition elastic file storage. It's just a file system that is basically mounted onto your instance, right? So you essentially will have a location where you can say that, okay, once we go to that location, you can essentially access that particular file system, right? So this basically works mostly for Unix-based system. We don't have support for that on Windows, and I didn't have the chance to test this out for Mac, so I wouldn't be able to say for certainty if this kind of runs for Mac as well, but I'm guessing it should be able to do it, right? And where we say that elastic block store is something that we work with EC2 instances itself, file systems can be used for a variety of different other services. The other services meaning other than EC2. You can use it for Fargate, which is another architecture for serverless application, Amazon Lambda, which is another serverless applications and stuff like that. So you can attach all those data that you need to run for these different types of functions that will be created within these different services. And then you can mount those file systems onto those services itself, right? And this kind of helps with like quick read and write of data and then moving data around in a much easier fashion compared to storing it in a block store, okay? And then finally, you have the simple storage service, or better known as S3, okay? S3, in distinction to the other two different types of services, is deployed across the entire availability zone. And it does not have a restriction with respect to what type of data it can store. It's like, you know, they call it a bucket, right? So you can pour whatever you want into bucket. So it could be like basically analytics data. You can put text files into it. You can put application data, any kind of is being generated, any kind of media information, any kind of backup or archival information. So what we do essentially is when we take a backup, we create a snapshot of the elastic block store, but when we want to save that backup, we actually put it in the S3 bucket. So as a result of that, throughout the entire availability region, we can access that backup and not in a particular subnet itself, right? So that is the whole purpose of ensuring that we have S3 there, right? So again, to recap some of the key features, and you can kind of keep a note of all of these different features, just, you know, so that you're prepared if you're taking the certification exam or you're sitting for an interview of sorts, is the fact that the block storage okay, is basically volume or a network drive that you connect over the network, right? So that is why we are essentially saying, and when you connect that to EC2 instances, we mount it as a drive, okay, and not as a file system in itself. Compared to that, EFS, or the file storage, is mounted on the EC2 instance, but it is deployed in an availability zone as well, just like you have for your EBS. The distinguishing factor of EBS and EFS from S3 is the fact that these two are AZ deployment, that is, it is deployed within an availability zone, and then S3 is deployed across the entire region. So that means no matter which zone it is, they will all be able to ping S3 depending on the permission policies that is associated with S3, all right? One of the important things for your file storage is they are not drives. You cannot partition them. So please keep that in mind. And then the way you connect to your EFS service is through the network file system protocol. So essentially what this means that the security group must allow this traffic. Okay, so you have to remember that since this will be connected to EC2 instances, right? You're essentially trying to mount these file storage to your EC2 instances. So this cannot happen unless the security groups allows for this traffic. So essentially you have to go to your security group when you're working with EFS, and you have to edit it to allow for inbound rules for NFS traffic, or network file system protocol traffic, right? So for those who are just, sitting right now, you guys can go and edit the security group and add this inbound rule. Okay, if not, we can do it together when I get to it. All right. So it's suitable for Linux based. And then the benefit that you have is that you necessarily do not need to have an EC2 instance running for you to be able to access the EFS. You can outside basically VPN and then connect to these file storage systems, which are running separately as a service on AWS itself, right? So the best example right now is, remember that for OU, right, for our university, we have these drives that essentially comes when we log into these computers, right? You can connect those drives, you can mount those file systems to your local computers if it is outside the domain of OU as well, if you VPN into OU's university. So you can access your student drive through that service. That is a very good example of what EFS enables, essentially what we can achieve through EFS, okay? Again, S3, of course, it is an object-based storage system. That is one of the things that you have to keep in mind. It is a container for basically any type of data. It's just treated as an object. What is inside, it doesn't care for that. Okay. The main distinguishing factor is that it is deployed in the whole region and it is not specific to an availability zone. So please at least remember this one. And then in order to access it, we use an URL. Remember when we saw that previous exercise, we saw that we have this S3 protocol. And then based on that, we had a URL. And that URL essentially allowed us to locate that S3 bucket that we were working with, right? The name that you gave. So your name of your S3 bucket is basically how it is kind of identified, right? So that is how we kind of access our S3 buckets. And the traffic or the protocols that is used is basically through REST API calls. So if you have ever worked with web development before, you kind of know that there are different REST API calls if you have developed RESTful APIs. Okay, or RESTful web services. So if you want to read the data, you essentially have to kind of execute an HTTP GET request. If you want to kind of select something, you can select. If you want to delete something, if you want to update something. So all of these different options are executed through RESTful API calls, right? So that is what you have to keep in mind. So anyways, so we have looked into EBS before. What we are going to do is kind of create it separately, and we are going to kind of connect it to the EC2 instances as a separate service, rather than kind of defaulting to the Elastic Blob Store when we are creating these instances, right? So you guys can download this and you guys can work with me one by one, and I'm just going to follow the instructions as well here. And then we are going to see how we can work with EBS, right? So the main thing for EBS that we will kind of pay attention to is not the fact of mounting it to the EC2 instances. That is not the most complicated business in the whole world, right? Essentially, what we want to have an understanding is that how we can create backups through snapshots and how we can kind of use those snapshots to create our own self-defined machine images. So those are the two steps that we want to perform, right? All right, so we already talked about it. So let us just get into the process. So from the left vertical menu, under this subcategory of Elastic Block Store, the first place that I want to go to is basically the volumes, right? So right now, no EC2 instances are running. If there were any EC2 instances that was running, we would have seen some kind of EBS volumes that will be present here. But since we are not working with anything, we're just going to hit create volume, okay? Again, the first option, you get all of the different options that we just talked about, some of the categories that we discussed. So we have the general purpose SSD, the GP2, I just keep thinking of Chat GPT all the time. And then we have the provisioned IOPS, depending on the category of operation, the cold HDD, hard disk drive that we talked about, throughput optimized. And then you have the magnetic tapes, not the magnetic tapes itself, but the slowest option that is there, right? So you kind of have to decide what you want to work with, right? Because if you want to have a small value and if you know what the purpose is, then you choose the category of the volume that you're trying to work with, right? Size-wise, it gives you kind of 100 gigabytes and stuff like that. But you kind of have to think with respect to what you're working with. So let's say if I choose something like this, you have to decide how many input-output operations will be performed, right? And the way you calculate this, there is like this rule of thumb value that is available for us to kind of understand that, is that for every gigabyte that we allocate, right, you can support up to 50 input-output operations, right? So now if you are working with, let's say, an IOPS SSD, right, and you need to figure out how much volume that you do, right, or how much volume you want to kind of associate to that, you need to ask yourself that what is the threshold of the number of input-output operations per second that you will essentially execute. And based on that, you multiply that to the times of gigabyte that is required. So as we said, oh, if I want to support, let's say 500 input-output operations, then how many gigabytes of volume do I need? Well, essentially, we need 10 gigabytes, right? Because that is based on this rule of thumb that for every gigabyte, we can perform up to 50 IOPS operation that we want to do, okay? If it is not IOPS that you're working with, so essentially then you can just select your essentially provisional it with general purpose CPU, because, well, if you don't know if it is customized with something, then you can leave it as such. Don't do 100 gigabytes of size. Let us just keep to the traditional one and let us just do 10 gigabytes, okay? So that we can make sure that we have some space addition to what the usual gives, right? And this is zone-based. So what I mean by this is that if I declare this particular volume in zone 2A, then if I have an EC2 instance in zone 2B, that will have some difficulties to connect with this, right? So wherever you're declaring this, please make sure that that is where you want to mount it, essentially, okay? This is not a problem with S3. S3 is accessible across. So here you can see that we don't have the option for multi-zone selection. So that means this particular volume that we are creating separately from an EC2 instance cannot be accessed across zones. That is something that you have to keep in mind. So let us just select 2A. And now the EC2 instance that we want to create should also be in 2A if we want to connect this particular volume to that EC2 instance that we are working with, right? Then we have an option for snapshot, okay? We don't want to kind of create any snapshots right now. We will do that separately in a separate exercise so that we can focus on the snapshot itself. If you want to apply additional security, you can encrypt that volume, but it's going to slow things down for obvious reasons of encryption and decryption. And if everything looks good, you can just, create the volume, okay? And then pay attention to what is happening in the volume state. And then essentially, it will kind of take it into account. So while we wait for this to work on, we are essentially going to create a Windows instance. And then with some UI support, we are going to see how we can attach an existing volume that we have created, separated from the EC2 creation process to that, right? So we're going to go to instances. we're going to click on launch instances, and I'm going to move a little bit faster here, okay, because we have already covered these steps before, but please stop me if you have any questions, right? So let's give it a name. So I can just say test window, and then we can put block store. Okay, or I can just say vstore, something like this. So I'll test it with a Windows instance and test my Elastic Block Store. Okay, let's put an EB store here. Okay, for our messaging image, we are just going to use Windows. So I'm going to search. I was just going to default into my Linux. So there are different options here. We have the Windows Server 22, the 2019, the 2016. You can just select whatever you want here, as long as it is a Windows instance and it is free tier eligible. You can work with it. So let me just select, let's say, the Server 2019 base. Okay. And then the instance type T2 micro, key pair login. I will just select demo of this. I will select an existing security group, which is my demo SG Ohio. The default storage that Windows provides me is basically a 30 gigabyte general purpose volume. I can change this if I know if I'm using it for a different purpose as well. So you can see there that the creation of the block store volume that will be by default attached to your instance can also be done here. So every step we did, but we're just taking an additional step just to understand how we can work with it separately, right? If you want to give it some information, you can give it all this information. If you want to provide it with IAM profiles and stuff like that, you can associate that. If not, everything remains default, okay? And then just hit launch instance. Okay, so let it go through this process. This will take some time to instantiate and then generate the password. So it takes about up to 4 minutes of time. We can go back to our volume and kind of refresh this. Okay, so now you can see here, we had created one volume, which is 10 gigs in size, which is available now. And you can see here the one that we have already created with respect to our instance, it says in use. So that means it is kind of attached to the instance that is being launched, right? So it will take care of all the different processes and stuff like that. So what we want to do essentially now is that we want to understand the process of how we make this available into in use. Essentially, that's the goal that we want to enable. Okay, so let us wait for our EC2 instance to kind of come to life. And we will take a little bit break here until this passes the status check and it kind of generates its volume. So I'm going to pause the recording right now, and we're going to take a 3 to 4 minutes break and come back again. So on my clock, which is running slow, so it's 6:40 right now. So we will resume again in 6:44. Okay, so please be here by 6:44. All right. So our status check has passed. So essentially this instance is live now, and hopefully it has also generated the password for the Windows connection. So what we are going to do now is basically kind of remote desktop protocol in to this particular instance, right? So select the instance, go to connect, okay, and then go to RDP client, right? And then connect using an RDP client. If you are on Windows, then you already have the RDP client with you. If not, then essentially you have to download it separately, and you can look at the previous slides that we have, and I have provided you the link with respect to your EC2, your RDP clients that you can use for Mac and Linux distributions specifically. Now, Windows is a little bit different in the sense that its AMI username is administrator, okay, compared to that where you have a Linux distribution, the Amazon's Linux distribution or some other Linux distribution, they use the default username as EC2-user, right? And then this is the public value that you're going to be working with. But what we have to do here is go through the process of getting the password, okay? So essentially what we had done when we had created this Windows instance, if you have not worked with this before, is that we have associated a key value pair with it, right? So we need to upload this key value pair and then decrypt the actual password and then save that password somewhere, right? So I'm going to upload my private key and then upload it again. So for a moment, I will stop the share here. upload my private key, and then hit decrypt password and resume my screen share, right? So once you resume the screen share, not once you resume, once you upload the decrypt the password, then it will give you this password like this, right? So right now, there are 3 pieces of information essentially that you need in order to RDP into your instance, specifically the username, the address of the computer, which is the public DNS, and the password itself. So if you're on Windows, then essentially hit on the search icon here, and then just look for RDP, and that will open you the RDP client for Windows. Go to show options, and that will give you all of the different factors here. Then the first thing that you need to do is copy the public DNS itself that is there, which is the address of the machine. Come here, select everything and paste it. And then in the username, you essentially have to give administrator. So administrator, okay, hopefully I have not made a spell problem here. So I'll just copy it from there, and then hit on connect. It will ask you for the password. At that point, you just select this password here. Please make sure you save it somewhere if you're going to do it later on. All right, and then hit OK. It will give you a prompt. You just hit yes, okay, in terms of the certification. And that essentially should launch your connection to your EC2 instance that is running the guest operating system distribution of Windows, right? So this goes for both the 22 version of Windows, 19, 16, depending on what you're going to work with. It works the same way, okay? So we'll give it some time, let it kind of initialize itself. Things take time. Okay, so once that is done, essentially we would want to kind of go and look for, in this particular search operation, we need to find what is known as disk management. It's kind of slow. Okay, so here, when you go to disk management, this is essentially what will enable you to kind of create new partitions or add new partitions and stuff like that. So right now, you can see here that we can only see the principal drive that we had associated with it when we had created this particular instance. So that is basically the 30 gigs drive, which has a free space of 40% and stuff like that. So right now, what we want to kind of achieve is that we want to take that separate volume, which also exists in the same availability zone, and we want to attach that as a drive by connecting it over the network to this particular instance that is running. Okay, so to do that, we need to kind of minimize this RDP protocol here, let it keep running in the background. Okay, we don't want any of this business here. So all we need to do is go back to our volumes here. So in the volumes, we can see that it talks about the available different types of stuff that we have, right, already that we have. So once we kind of select the volume that we kind of want to attach to that particular stuff, right? So there are 2 different options here. You can either directly right click it and it will give you all of the different options that is associated with that volume, or you can select it, go to this actions bar at the very top right corner, and you will get the same sort of volumes that you will get the same sort of options that is associated with that volume. So what we want to do is essentially attach our volume. So we are going to click on attach the volume. Okay, so here it will ask you for the instance that you're trying to attach it with. So this is the zone that it is available. So if the instance is not running in this zone, you're not going to be able to attach your volume. So that is one thing that you have to keep in mind. So this is the only thing that is running. We can see the test Windows Elastic Block Store. We have given it a name, so we can click it. And then you get the option of device name. Now, device name, you can see that it's something very funny name, volume name that is going on here. But essentially, keep in mind that you have the option to give a device name, which starts with this XVDF character to XVDP. Okay, so you can choose any combination of letters that kind of falls between these 2 options, and you can select that, right? So once that is taken care of, you just say attach volume, and that's it. It is as simple as is to kind of attach that volume, right? But now goes back we need to kind of go back to our instance. And we need to kind of see here, we can see that the disk 0, which is the basic 30 gigs is there. And now we can also see this 10 gigs of file that we have attached through the network, right? But please notice here that it doesn't say it is online. So that means that if you simply attach it, it does not get initiated with the instance, right? So we need to take a few more steps here. So what we need to do is we need to right click this area where it says unallocated, okay? And then we need to kind of go through the process of getting this to go into online, okay? So let's give it some moment and let it go through the volumes process. So give it some time. Okay, where is it? Where is that visit? Unallocated, we don't want the help. Okay, here we go. So initialize disk, okay? And then leave it at the default volumes that you have here. And we just hit okay. And then we basically have this in online as well, right? So we have to take just one more step in order to kind of get this drive to be online as well. So now we have basically two drives which we have associated. So the one, which is when we did the instance initialization, when we clicked on the volume that will be attached to it. And then if we have a separate volume, then that is also something that we can work with and attach it separately, as long as the only restriction that we have is that the instance as well as the Elastic Block Store volume that we have created needs to be in the same location, as that means the same subnet or the same availability zone that you are working in, right? If they're not the same, then you cannot connect it. And if you ever need to kind of take it off again, then you can right click on the disk again, convert it, make it go into offline mode. You can check the additional properties of these disks. What are the policies that are associated with it, information about the volume, the driver details and stuff like that. So everything that you basically get to see in your local machine, if you're working with a Windows operating system, you get all of those information accessible to you, right? So I can take this off of commission again. I can just get it to be offline, close this disk management window, minimize my RDP if my Zoom kind of gets out of my way. Yeah. And then all we need to do now is, if we want to just simply get it out of the commission, then just right click on it. Okay. And then you can force detach the volume. The reason why we see here force detach volume is because since we have already connected that and we had taken it one step where we had got it online with respect to the instance, it's like, the safe process where you insert a USB stick onto your machine and you need to right click and you need to say eject this volume and then it gets ejected. The same thing is kind of happening right now, is that since this has already been connected, until and unless you terminate that particular instance, you are not going to see an option where you can kind of safely remove this volume. But if you want to do it, you can simply click on force detach volume, okay? And it will give you a warning that what you're doing is not safe and stuff like that. You might lose the data if there is some process that is running and then writing it onto that particular volume. So just be aware of those kind of use case scenarios, that you don't kind of force detach the volume when some process is kind of going there. So just make sure that you are safe in that sense, right? So just hit force detach and it will come off that whole process. And here I can see that a snapshot has already been created for this particular instance. But this is basically something that you can work with, that you can create volumes that are independent of a particular EC2 instance, or you can create those volumes while you are working on them. And then essentially that will allow you to kind of work with these volumes. Okay. So in addition to these, like in addition to connecting EBS volumes over the network, there are certain storage options in EC2 that is provided by AWS that runs on the physical devices itself, right? So wherever your EC2 instances are being created, remember that is a virtualization platform, right? So there is some option that the physical platform that supports your VM there, your storage can take place within that physical platform itself. But the problem, these are known as instance store volumes or ISVs, okay? But the only drawback is it's going to give you very high performance and high latency, because you are essentially asking those storage volumes to be created on the same physical platform where your VM exists, right? You don't know where exactly that is, but you're essentially requesting your storage to be created in that area itself. But the disadvantage is that these storage volumes are going to be non-persistent, right? So that means when you shut down your instance, you're going to lose your data. That is something that is going to happen. So this is a trade-off that you need to keep in mind, that there is an availability of these instance store volumes. So if you want very low latency and high performance, operations of the data set that you're working with, your processes, and that is associated with your instance, you can kind of request for this. Okay, it only depends on what type of instance store volume that you're selecting, general purpose versus IOPS and those kind of things. But just for requesting the instance store volumes, there is no additional cost. Please remember that, right? So cost model is something that you have to remember based on the services that you're working with, right? So now we already talked about the fact that, these EBS volumes are specific to a zone, right? It's specific to an availability zone. So what happens is that now, let's say in this situation, I created an instance in 2A, right? And this volume was attached to 2A itself, okay? Or it was declared in 2A, it was attached to my EC2 instances. Now, let's say if I create an EC2 instance in, let's say, 2B or 2C, how do we take this volume and the data of this volume, which is basically sitting in 2A, and how do we connect that to an instance that is running in a completely different subnet? So the motivation or the objective of our second exercise within the storage section is to understand how to take snapshots. Okay, snapshot essentially helps us in multiple different ways. First of all, the most immediate use of snapshots. So essentially, snapshot is this second menu option here under block storages, and you can create a snapshot here. It will tell you, okay, what do you want to take a snapshot of? Do you want to take a snapshot of your storage? Do you want to take a snapshot of your entire instance itself? So it can save the stage of like the entire state of the VM itself. So remember, we talked about live migration conceptually before, where we talked about, it takes a copy of the existing state of the VM. You can keep a track of what is happening, and you can do the live migration as if nothing happened, so to speak, right? With a very little downtime. So that is the snapshot part, which kind of supports the instance snapshot, or you can just take a snapshot of the data itself. And the very immediate usage of taking a snapshot of the data or taking a snapshot of the instance is to create backup, right? That's the foremost thing. The second utility is the exercise that we are working with, is that if you want to kind of migrate a particular volume from one subnet to another subnet, the only way to do that by retaining its state is by creating snapshots. Because essentially the way it is enabled is that whenever you create a snapshot, the snapshot is saved to a default S3 bucket, which is serving your particular region, right? So you can access that snapshot through that bucket. And remember, since the bucket is deployed to the entire region, so that means it is available across all of the different zones that are there, right? And the third benefit of working with snapshots is that, let's say if we go back here, where is my volumes? Okay, so I can see here, this has gone back to available since it was detached. This volume here was basically the primary drive of this instance, not was, is basically the primary drive. So you have the machine image that is sitting within this. In addition to that, you have all the other different software stacks that are running within this. So what happens now is that if I make some editing on the software stack that I need, and I create a snapshot out of that, and I register that as a machine image using that snapshot ID, then I basically am creating my own machine image from a template but that is customized based on my requirement. So that is the process. If anybody is wondering that how do I create my own machine image for, let's say, my own organization or company, you start with a host distribution. So maybe it could be a Linux, some variant of Linux distribution. Maybe it could be Mac, maybe it could be Windows, whatever it is that you're working with. You add your software stack, whatever you're doing, okay? Then from the primary drive, you create a snapshot, and then you take that snapshot and you go and create your own AMI. So when you go to AMI, there will be different options here, okay? Register instance store backed AMI, okay? So this is where you are going to be registering your option, okay? Other than that, here you will have different options with respect to, you can create template with AMI and then launch different instances with these AMIs. So essentially, this is where you will be dumping your AMI, but first you have to request to register. Request to register costs money, by the way. Please keep that in mind. So if you are going to be submitting your own AMI to the AMI catalog, they're going to charge you. So please make sure that you deregister your AMI once you're done essentially working with that, right? So, okay, coming back to our snapshots again. So we will follow the steps for exercise 2, that is in slide 13. We're going to follow it step by step, right? So we're going to hit create a snapshot. We're going to make a snapshot of our volume itself. And here we can see that we have 2 volumes that are available. I just need to find what is my volume name for the 10 gigabytes one that I had created. Where is my snapshot? Keep missing it here. Okay, so I have the 063, which is the 10 gigabytes, and then I have the 04F, which is the actual C drive here, right? So you guys can choose whichever snapshot you want to take. There is no restriction that you have to do the 10 gigabytes only. You can do the bigger one as well if you want to kind of keep on using the same snapshot for maybe exercise 3, which is to create your own AMI image and then register it as well, right? So here, I think I said 04F was the 10 gigabyte, and here we can say some description, and we can say test using snapshot. Okay. Nothing is encrypted, and that's about it, right? So we just create a snapshot, and we need to give it some time because it's going to go through that 10 gigabytes of data, not data, but space that is there, and it will see that nothing is there. So what you could have done is when we added that drive to Windows, maybe we could have added a file there just to kind of show that it is something that is there. So this is going to take time again, but essentially what happens afterwards is that you need to go to that new availability zone. And then when you create your new volume, you need to create the volume using an existing snapshot. That's all that there is to it. And once that volume is created, then you can attach that volume over the network to any EC2 instances that is working there, right? So essentially, once this becomes available, what you do then is you go to your volumes, right? And then you need to create a new volume here, okay? But instead of creating a volume afresh, as we did in the previous step, if you see here, it asks for the snapshot ID. And what we did previously was that we said that don't create a volume from a snapshot. But this time, when we are going to create the new volume, and that new volume will essentially be in a different subnet or a different availability zone, we essentially have to find whatever the ID is for our snapshot once it is ready. I think it was already given, and then just specify that. Once you specify that, just hit create. And once it is created, you will have kind of migrated or made a backup. So you now know how to make a backup of either your storage or your instance, the whole instance itself. You know how to migrate that backup to and deploy that to a different availability zone or a different subnet, and then attach that to another volume, right? So is this step clear? We just have to change this 2A to 2B and we create the new volume there. Does everybody follow this? Can I get some feedback?
Yeah, it makes sense.
Yeah, okay. Okay, so I'll not go through with this, and we'll just, so this is done. It is pretty quick. If you have more data, if you have more instance states that is running, then this is going to take some time. So what you can do here is you can create a volume from snapshot by directly right-clicking on this. And you can see here that there is another quirky option that is right after creating a volume. Because if you create a volume from a snapshot, it will already select that. And you can create that what is going to be the volume type. And you can decide where you're going to launch it. So I'm going to move it to 2B, right? And then that will kind of enable that, right? But if I don't want to do that, then there is another option that is available for us using the snapshot. And you can see here that it says create an image using a snapshot. So now if you go there, then you can follow through these different options of creating your own custom image, assuming that you have a software image in that. This particular snapshot will not support that action because we did not create a snapshot using a drive or volume that had a machine image to begin. But however, if I create a snapshot of this particular volume, which is my 30 gigs volume that is hosting my Windows 2019 server image, and if I had, let's say, added more software stack to it, then essentially what I can do is I can right-click that, create a snapshot first, and then go to my snapshot. It's a two-step process. Go to the snapshot, right-click on the snapshot itself, or go to the actions. You can do it from different places. Go to actions, but essentially what you're looking for is our third exercise, is create an image from the snapshot, right? Now, what are the fields? Give it some name. Nothing too complicated about it. Give it a small description. You can describe your own software stack, okay? Specify the architecture that you're going to be working with. So either the x86 architecture or the ARM64 architecture that you're going to be working with, or if you're working with the x86 for Mac, then you can select that architecture as well, okay? Provide the root directory's name, what kind of virtualization that you're using. So again, if you don't remember this, we had discussed this when we were talking about the different types of virtualization. We had talked about hardware-assisted virtualization, where we don't implement the virtualization directly at the OS level, but we don't embed it completely in the hardware level, but we put it somewhere in between where the hardware has some assistance and we implement the virtualization in a software emulated fashion. So that is the hardware assisted. And then there was para virtualization, which is the para true virtualization. If you don't remember this, please look that up again, read that up, okay? Everything else remains default. You can use the boot mode. So you can specify everything that is necessary to create your own image. And once that is done, you just create the image and that will register it. It will ask you to register it with the AMI marketplace, right? No random images can be registered, right? It will go through a check to make sure that you're not putting anything malicious, right? I can very much install software stack that can compromise some, innocent user who thinks that that is exactly what they're looking for, right? So you cannot just simply, submit, create and submit. Once you create it, it will tell you that Amazon will go over your image that you have created. And once it is ready, then essentially what that means is technically your image is registered with the AMI catalog. And other people, if you have set it to public, can access your image in order to build their instances as well, right? So that is all there is when it comes to your EBS volumes. So the important takeaways when working with EBS volumes is, of course, you need to know how to create volumes. Okay, and that is a very simple process, right? You just go create the volume, specify what category of storage that you're using, provide how many gigabytes space you need, and just create it, right? But what is important is you need to know how to attach these volumes to instances that you are launching. And the important thing here is you have to remember that these volumes, that this Elastic Block Store volumes are AZ specific. So that means it is not multi-AZ deployment. You cannot access a block store, which has been declared in a particular availability zone, across all the other availability zones that kind of is available within a particular availability region. So that is something that you have to keep in mind when you're working with block store. And the next thing that you have to keep in mind is It is accessed over the network. That is kind of straightforward, but you can create snapshots, and that snapshots option is something that is available as a sub option within the Elastic Block Store itself. So whenever you're working with snapshots, so snapshots can help you create backups. It can help you migrate to another AZ, okay, whether you are doing it for your instance or whether you're doing it for your volume. So remember, snapshots can be done both for the entire instance, and it can be done for just the storage volumes that is attached to those instances, whatever snapshot that you want to create. And then finally, snapshots can be used to create custom machine images. That is your own machine images. But the way to do so is to first by creating a snapshot of the storage volume, which actually holds the bare bone machine image, on top of which you're creating your scratch, right? So you don't create your own OS distribution as such, right? That will be a different story. So you take something that is already there and you add on to that. So let's say there's those processes that we were running, right? Where we were talking about creating the web stack, where it turns each and every operation into a web operation. What we can do is we can take that instance that we had created. So this is, if you think about it, if you can take that entire instance, okay, we have already installed those software stacks. That means we had installed the HTTP AT client, the daemon that was running there. We had added some HTML data there. So if you want to create that as a machine image template, you take a snapshot of that and then right click on that snapshot, okay, and then create a machine image and then register it with AMI. Once you do that, that's it. From the next time, you don't have to run those additional commands as a user data. It is available to you as a custom machine image where you're building an instance which has the Apache server, and then it also has the set of files that is hosted on that particular instance itself, right? So the possibilities are endless if you know what exactly that you're trying to do, okay? But please, if you go to the point where you have registered, deregister it, because if you register your machine image that you have created here, it will cost you money. It's not covered by free tier account. So if you go through the steps that are there in the slides towards the very end, please make sure once you're done to deregister your machine image itself, okay? So I think the next exercise is EFS, but I think we will wrap up here. And in the next class, we will kind of cover EFS and storage, and that will S3, and that will cover the main storage aspects of AWS. And then we can start talking about databases a little bit, okay? So if there is any question, you may ask now. Otherwise, I will see you all again online on Wednesday evening, okay? And please do not forget to destroy any resources that we had created in today's exercise if you are working with me. And whenever you do work separately, if you choose to do that, please make sure you destroy all of your resources once you're done working or demoing them out. Okay, thank you.